Hey there, 6th grade. In this next video, we're going to look at another geometrical figure called an angle. An angle is formed by two rays that both share a common endpoint, and that common endpoint is known as the vertex of the angle. So here is an example of what an angle looks like. This angle is formed by the ray BA and the ray BC, and they both share a vertex, which is the point B here. You can name angles in three ways. So you can name an angle with the capital letter at the vertex. So for instance, this angle here could be named as just angle B, and this is our geometric symbol for angle. You can name an angle with the number inside the angle. So notice how there is a number 1 here inside the angle. We could also call this angle 1. And then finally, and this is going to be the way we more often than not name our angles in this class, you can use 3 capital letters so that the letter at the vertex is in the middle. So for this angle here, you have 2 options for this last way. You can name it angle ABC, or you can name it angle CBA. Okay, all 3 of those points are on the angle, but that middle value B, that has to be the vertex. Okay, so that's how 3 different ways you can name angles. Angles are measured in degrees. And the symbol for degrees is this little sort of a circle that you put up top next to the numerical number that represents the measure of the angle, sort of like you do temperature when you're measuring Fahrenheit and Celsius. And the tool we use to measure angles is what's called a protractor. And we won't be using those in this video here, but at some point we'll be looking at how to measure angles using protractors. So in these next 4 examples, you're given a figure on the right-hand side, and you're just going to be giving the measure of each angle. Number 1, they're asking us to find the measure of angle EAD. So when we write this, we're going to write this with the following notation. We're going to write it with a little m and then the angle EAD. And what this stands for is this stands for the measure of angle EAD. And then we can write equals, and we'll list whatever that angle measures. When you're giving angle measures, it's really important to include that m there because, again, that stands for measure of. Don't just write angle EAD equals. Make sure you put the m out in front. Think of that as proper grammar for geometry class. So now the question is, what is angle EAD? Well, it's the angle that goes through points E, A, and D, with A being the vertex. So if we look and find point E, we see that's here. This ray goes through point E, it hits the vertex of angle A, and then this other ray goes through point D. Okay, so this here would be angle EAD, and it measures 105 degrees. Notice that they didn't just ask us to find the measure of angle A, and that's because there are a lot of different angles in this diagram that have a vertex of A. This angle down here has a vertex of A, as does this angle, as does this one, as does the one we just highlighted, as does this one. So in diagrams like this, it's really important to name the angles using those 3 capital letters, because otherwise you would be confused as to which angle they meant as angle A. Okay, number 2, angle CAB. So we're going to find the measure of angle CAB, and that would be the angle that goes through point C, has a vertex of A, and then has another ray going through point B. That is this angle here in orange. It measures 45 degrees. Next, angle DAB, we're going to find the measure of that. That's the angle that goes through the point D, vertex of A, and also contains the point B. So this angle here in blue. Notice this angle is made up of 2 smaller angles. Okay, it's made up of one angle, angle DAC, that measures 30 degrees, and it's made up of another angle, angle CAB, that measures 45 degrees. So the measure of this angle, DAB, is going to be the sum of these two smaller angle measures. So it's going to be 30 degrees plus 45 degrees, and so that means its measure is 75 degrees. Okay, finally, angle FAC. Here's point F. There's the vertex A, and then notice C lies on this line here. Okay, so it keeps going like this. Now, at first glance, it may not seem like this is an angle, but because it lies on a perfectly straight line. But this is actually a type of angle. It's what's called a straight angle. And we can find the measure of this angle by looking at the three different angles that make up this green line. So notice that this angle here is comprised of three smaller angles. This angle, which measures 30 degrees, this angle, which measures 105 degrees, and then this angle, which measures 45 degrees. Okay, so it wraps around all the way this way. So if we add all three of those angle measures together, 30 degrees plus 105 degrees plus 45 degrees, we see that it measures at 180 degrees. And you're going to find that's true for all straight angles, and that's actually what we're getting to next. So go to the back side, and we're going to look at how to classify angles. So angles can be classified based on their measurements, and we have four different classifications for angles based on their measurements. We have what's called a right angle. A right angle measures exactly 90 degrees, and our symbol for a right angle is they'll put a little box inside the angle to represent that it's a right angle. So this little symbol here means that this is a right angle measuring exactly 80 degrees. And acute angle is an angle that measures less than 90 degrees. So anywhere from 0 to 89.99999 degrees would be considered acute. An obtuse angle is an angle between 90 and 180 degrees. So anything above 90 or less than 180 is obtuse. And then a straight angle is one that measures exactly 180 degrees, and it looks just like a straight line. So here in examples 5 through 7, we're just going to tell whether these angles are acute, right, obtuse, or straight. So starting with number 5, we see that little box inside that angle. So because of that little symbol there, we know that this is a right angle. Number 6, this angle appears to be wider on the inside than a right angle. Okay, so that means it must be an obtuse angle. It's more than 90 degrees, so we would call it obtuse. And then number 7 here, this angle appears to be more narrow in the degree measure on the inside than a right angle, so it must be less than 90 degrees, so it's an acute angle. Okay, finally we're going to learn about what's called complementary and supplementary angles. If the sum of the measures of two angles is 90 degrees, then we call those two angles complementary. If the sum of the measures of two angles is 180 degrees, then we call those two angles supplementary. So in the figure below, we're going to identify one pair of complementary angles and then one pair of supplementary angles. So for complementary, remember complementary means they have to add up to equal 90 degrees. Look at this picture, look at this diagram, and can you find two angles who, when you add their degrees together, you would get 90 degrees? Well, one possibility is one of the 40-degree angles. So angle AEF, this angle here, measures 40 degrees. And if I add a 40-degree angle with a 50-degree angle, I get 90 degrees. So another option is angle AEB. This angle AEB, measures 50 degrees. So that means that these two angles, angle AEF and angle AEB, are what are called complementary. Okay, they're complementary because the measures of their degrees add up to 90. Okay, one pair of supplementary angles. So we want two angles whose angle measures will add up to 180 degrees. Okay, at first glance it looks like we can't find any two pairs of numbers that add up to 180 degrees. But let's think a little bit outside the box. Remember, we can add two smaller angle measures together to get one larger angle. So notice you have a 90-degree angle here and a 40-degree angle here. Well, that means that this angle, this would be angle BAD, must measure at 90 plus 40, or 130 degrees. So angle BED measures 130 degrees, and then we already know angle AEB measures at 50 degrees. If I add 130 plus 50, I get 180. So that means that angle BED and angle AEB are supplementary. All right, if you had any questions over this video, make sure you have those written down for the next time. And until then, have a nice day. You're all wonderful people.